Hey, we're going to rewrite this one in factored form first. Notice it's already in expanded form. We have x's, x squareds, and we have numbers the same. So I'm going to factor it. 12, it's a plus, so factors of 12 are 12 and 1. That adds to 13. Doesn't make 7. 6 and 2, 6 times 2 is 12, adds to 8. 4 and 3, yes. 4 and 3 will add to make 12. So, I know that. And the bottom, 6 minuses, has to minus, well, that's 5 minus 6. 6 times 1 is 5, which minuses doesn't make it. And then the other one would be 3 and 2. All right? So, they'll factor to that. So, all right, so it will factor to this one right here. All right? So, here's our factors, which will make it nice then for us to have that. So, here we go. So, how do we do the y-intercept? Which side did we box in? The right side of which one? The expanded or the factored? I like that one. The expanded one. We're going to box in the right side of the expanded. And basically, very simple. What's 12 divided by negative 6? Negative 2. So it's the point 0, negative 2. So the y-intercept is what? 0, negative 2. I like the fact all the y answers are the expanded one, and they're left or right. So the next one, I just kind of gave a hint. The horizontal isotope is a y answer, so I'm going to box in the far left, and this would be 1 over 1, which makes it y equals 1 for a horizontal. Now, y'all, we're done with the expanded one for a while. Okay, we're really done with this one, because now everything else will be with the what? The factor form. That's why we write the problems out both ways. Okay? So that is this here. So now then, the hole appears. Is there a hole in this one? Yes. The hole appears when you have factors that are what? Exactly the same. We have factors that are what? Exactly the same right there. So what I do is I set this equal to 0. What will make this equal 0? Because you can't have a 0 down here, and that's negative 3. So the hole will occur when x equals negative 3. Yes?
Could you just like make it easier to switch the sign to negative?
Kind of. That's what. But that works only if it's an x like this here. Like if it's x minus 3. That works when that only works if there's not a coefficient in front of the x. Yes. Okay. Now you gotta remember this. The hole is kind of like a bouncer. It's going to kick people out of the what? X-intercept and the asymptote. So here we go. So here's the x-intercept. The x-intercept, we box in the top one, and we set these equal to 0. And kind of what you just said, that's going to switch these signs, because that means negative 3 and negative 4, except what did I say about the hole? It kicks it what? Out. So the only x-intercept is really just where? At what? Negative 4, 0. The x-intercept is negative 4, 0. That's it. Okay? Because the hole kicked it out. Right? Then the last thing is the vertical asymptote. Now we've boxed in the left, right, and top. So what's left to box in? The denominator. And you set these to 0. Except for once the same thing, what? The whole what? Kicks them out. So negative 3 will not be an answer, but what? Positive 2 will be an asymptote. Okay? So here's what's really nice. We just did all that work. So now we're going to go graph this. Oh, we still got the domain. What did I say about the domain? The domain is basically the same, except for the fact the domain still can include the hole and cannot include this here. The hole does not get kicked out of the domain, because you can't have 0 in the denominator, whether it's a hole or whether it's an asymptote, it can't be there. So the domain changes from not to not equals, and both of them are there. The domain's stronger than the hole. It used to be a bigger bouncer than the hole. Okay? Now, here's how we're going to graph this. And when I graph these, I always start with a vertical asymptote. You don't have to. I just think it's easiest that way. So the vertical asymptote we just worked, it was at what? 2, right? So I'm going to make a nice, now I like to make them red. If you have colored pencils, it's real helpful. Some dashes. Because it's not a solid line. This is not actually part of the answer. It means this answer is not here. Okay? The horizontal one occurs at just what? Y equals 1. So I'm not going to make another horizontal one right here. So what I know is my lines are going to be what I call curvy L's, I just don't know whether they're what, tops or bottoms, you know, where they're at yet. But let's find some points. We already know where the y-intercept is what? 0, -2, which is right here. So I already know there's going to be a curve L probably down here. And the x-intercept is at what? -4, 0. However, there is a problem with this one because there's going to be a hole where? At -3. So when I make my curve L here, I have to skip -3. And the way I show that is by making an open circle right there. Now, I kind of maybe graph it and then erase that part and make a little circle. Or you can make this, you don't really know where to make the circle until you what? Start to what? Graph it. Because if the line had been up here, I would have had to make my circle, I need to make my circle on the line. So that's why I kind of do it real lightly in pencil and then make a big circle there, because this shows me -3 is not what? An answer. This is the hole, this is the asymptote, vertical asymptote. Now, y'all, I know I had one curve L down here. How do I know whether the curve L is down here or up here? How can I find that out? I need to pick a number and plug it what? In. Now, this is at 2. I like to pick easy numbers. So what's 1 higher than 2? That's why I have this 3 here, because I'm going to pick a 3 because that's really what? Easy. Now here's what's nice. Notice, guess what happens right here? This is this times that, and that times that. So that's like whatever number's there is exactly what? The same. I'm going to cancel it out. Now, I can plug in this problem, or I can plug in this one. Why do you think I'm plugging in this one and not that one? Because this cancels out, makes the work a little bit what? Easier. And I'm going to put a 3 in there, so I'm going to have 3 plus 4 divided by 3 minus 2. I like 3 minus 2 because that's going to be 1. 3 plus 4 is what? 7. So that means my point is really what? 3 what? 7. So I'm going to put a dot at 3, 7, which is up here. So I know my curve L is what? Up here in the top. So it just looks like that. So this is what's pretty cool. Now notice, y'all, you have to have a what? A hole in the asymptotes for the graph to be correct. The curve L's, I call them in the right spot. But I also want to show you this. Okay? Here's another way to do that with the calculator. Now, I'm going to type in this number because that was the original problem. In case I made a mistake factoring, the graph will still show up correctly. Also, you can do this here under y equals. Oh, I turn it on first. Under my y equals, I'm going to clear that there. Like in a previous problem, you put all the numerator in parentheses divided by all the denominator in parentheses. But I've also found a new way. Calculator's been updated. If you hit second alpha, the green button, second alpha, and then y, this pops up right here. And I'm going to do this option 1, which will put stuff in, guess what? A fraction form for me. And then all the answers are going to appear as fractions also, which will make the work really good when you have to get like some answers. Sometimes people might prefer decimals. Decimals, you do it that other way. Fraction answers, you do this way. So what I'm going to do is I'm going to type in now my x squared plus 7x plus 12. And then I'm going to arrow down to this one. And I'm going to do my x squared plus 7, nope, it's not plus 7x, just what? Plus x minus what? 6. And I'm going to hit graph. And I want you to notice the graphs look very similar. They're not exact. That's okay. But notice here, do you see a hole? You can't really see the hole because the calculator has tiny pixels. And we can't see one little pixel. But I can tell you it's going to where -3 is, and then it's skipping over it, but we can't see that. However, if you go to second table, you can look up here and see at -3 there was an error, and at 2 there was an error. And what we say about our domain? Those were answers that were what? Not possible. And the other thing I think is really cool, as we get above -3, look at those fractions. They're getting really, well, those are fraction ones. They're going to get closer and closer to 1, but not B1. And this way here, they're going to do the same thing. On this side here, they're going to get really close to what? 1. And I do kind of want to show this here. Let's kind of get back up there where our error is. All right, there we go. Let's do the y equals. And y'all, I want to show you the difference here. If I type this one in here, x squared, I'm going to type in the very same problem, plus 7x, just so you can see the difference, plus 12. Oh, wait a minute, what did I forget? The whole thing's gonna be what? Problem, because what did I forget to do? You have to put these in what? Parentheses. So that's gonna be x squared, so I have to type that one over, plus 7x, plus 12, close the parentheses, divided by parentheses, because I got the whole thing in parentheses, otherwise it won't give me the right answer. X squared plus x minus 6, close the parentheses. Now I'm not going to graph it because that's the exact same what? Graph, right? But look at my table, second table. This one is fractions and this one's what? Decimals. Everybody see that? And you can see as we get negative, it's going to get real close to 1, but never be 1. And as we go to positives, they're going to get real close to 1, but never be 1 also. All right? That's just the difference with the fractions and the numbers. Everybody, so that might make it, that's the difference between those two methods. Sometimes the decimals are easier to see, and sometimes the what? Fractions are. All right? Just want to make sure everybody notes that.